Hello everyone, FunshineX here. We are back, ComputerCraft tutorials. This is number 5. I know I took a small break, but I was waiting for 1.25 to come out so I could show you a ton of new things on ComputerCraft. And then I got a little sidetracked on the Feed the Beast with DamnSky, and then a little more sidetracked with my Let's Play. But I've got some feedback from my viewers that they really want to see more ComputerCraft tutorials, so I am back to do more tutorials for you guys. I hope you enjoy this one. This is all about the Redstone API that comes with ComputerCraft. We can read and write Redstone signals over just a vanilla Redstone or a bundled cable from Red Power. So you'll see I have both ComputerCraft 125 and Red Power installed in this world. This is actually the same set of mods I use for my Let's Play. Just happens to have both those mods set up. So I've got some lamps, some bundled cable, various colors, and let's see what we can learn. Okay, so let's go over to the my code for the programs, and I've done it the same way I do everything else. I put a disk drive next to it. I edit the startup program to load my program at boot up and run it for us. So this RS tutorial program will run every time we reboot the computer, and it's going to print out this RS tutorial, and then you'll see this thing in LUA is sorry, I was corrected. Don't say LUA. It's not an acronym. It's Lua. It means moon or something like that. So in Lua, this means comment out this entire block of code. Whereas, just a single dash dash will just comment out one line instead of a whole block. Okay, so all this is not really running. It's just for informational purposes. If you look on the ComputerCraft wiki, you will find this API. Just type RS in the search, and these will all come up. So what do we have? We have rs.getSides, and that I'm not sure why that's part of the RS API because it doesn't do anything on Redstone. All it does is list all the valid sides of a computer, and that's right, left, front, back, top, and bottom. So if you run that, it's just going to give you an array of the sides of a computer. So not a huge thing, but it might be worthwhile if you want to enumerate over those and use them to check which side your modem's on or which side the Redstone input's coming in on. Since I'm usually writing these programs for myself in a specific build, I know what side the Redstone signal is coming on, and if it changes, I'll just go change my program. So, but if you're writing programs for other people, you might want to make them more user-friendly and search. Okay, well, where's the bundled cable connected? Where's the monitor? Where's the disk drive? And find out. Okay, so the next few, you got the get input, set output, and get output. These three are vanilla Redstone, sorry. Or you could use Red Power single, just red wires, red alloy wires. And so this just checks a single side, the state of Redstone. So you could also have a button, a lever, something else that's just going to the block above it, below it, to the left, right, front, and back, and saying, do you have a Redstone signal or not? Okay, so let's get input. You'll get a true or a false. Set output is how we turn things on or off. So if we have a wire coming away from our computer, we can say, okay, set the output of the backside to true, or turn it off, false. Then you think, okay, well, if you got get input and set output, what's this get output for? And if you read on the wiki, this tells you what the computer is sending. So if you've got a lever somewhere turned on and is providing a signal to your computer, get input would return true. But get output might return false because the computer's not actually sending a signal out on the left side or the back side or whichever side that thing's coming in. So I'll show that when we actually do some programming down lower. Right now I'm just going over the API. I've got some really cool programs down here. Okay, so then we've got 4 functions that do with bundled cable. So this is specifically for Red Power. This mod was written with Red Power in mind. Get bundled input. So this is very same as get input, but we're checking in a bundled cable which has 16 inputs of all the different colors. So this, instead of returning true or false, returns an integer, which is a bit. In binary it would be each bit for each color. And it's really not easy to work with, like red is color 32 or blue is, I don't know the exact numbers, but you don't want to remember that. So they've got this color API down here where you can test okay, well if I get a bunch of colors back, is red part of that color? Of the array of colors? And if so, it'll return true. You've got a thing to add two colors together or subtract multiple colors from the main color. So I'll show those again, but basically this I'm just going to print these here, it doesn't matter, it's just comment. But the get bundled input will give you an array of all the different wires that are on or off. Get bundled output is just like this one. It's saying which colors is the computer itself sending signals out. Technically you should know that because you're the one sending the signal, but yeah. Maybe you need to check a state or something. Okay, and then you have the set bundled output. So you'd say which side and which colors do you want on or off. Be careful on this one, because let's say I have a blue signal coming in from a lever on a blue wire, and I say set bundled output side, whatever side the wire's on, and colors, I only set it to the red color. Well, that'll turn red on, but it'll also turn blue off, and maybe I don't want that. So sometimes it's best to get the input to find out what's currently on, add using combine red to whatever was on, and then send the output. So just know that if you send whatever colors you send, those are the ones that are on. Everything else is off. If you want to turn everything off, just put a 0 there. Right here, just put an integer 0, and it'll turn all lights off. Okay, and the last function of the Redstone API is a test bundled input. This doesn't turn anything off or on. It just says, for this color, is it on or off? Just tell me. So that's really handy, just if you want to check a state. Okay, so then I've got some other useful functions that are not part of the Redstone API, but we're going to be using. The operating system API, or OS, has a pull event, and I showed this in my Let's Play with my read farm a little bit, but what this function does is it stops your program and it waits until an event occurs. And there can be multiple events. A key press is an event, wireless RedNet signal coming from your modem on your computer is an event, putting disks in the drive is an event, rebooting the machine or startup is an event, and the one we're interested in is the Redstone event. And that basically means somewhere on one of the sides connected to my to this computer, a Redstone signal turned either on or off. That's all it means. It doesn't tell you which color or which side. You just have to, check that yourself, basically. So we're going to call this pull event function, and then when it comes back, we're going to go through and say, okay, let's check what colors turned on or off and react accordingly. Otherwise, you just, like doing a timer and say every 5 seconds, maybe check what the states are, and you might miss something turning on and off. So this one's a really good to use. I mentioned a timer. There's a start timer, and you just give it a number of seconds. So 10 seconds, 1 second, 5, whatever. And when it comes back, you'll get an event called the timer event, and it'll also tell you the ID of your timer. So if you have multiple timers running, you can tell which one came back. And the thing to note here is this only runs once. So as soon as that timer event comes back, you need to start a new timer, and I'll show you guys that later. And then again, the colors API, I will show you how that works down in the functions. Okay, so the first thing we want to do is we'll just go through an example of each one of these functions and see how they work, and then we'll combine them all into some cool things later on. The first one is this rs_get_sides, and I just wanted to show you how that works. If you don't know Lua, this returns an array. We convert that to pairs, key value pairs. So key 1 is this value, key 2 is this value, and then it's easy to just loop, do a for do loop and print the value. So if I put an extra dash here, that removes this comment, so now this code can run. Let's go into Minecraft and just boot up the machine, and you see it's going to print out. Hopefully it prints out. Let's run in a different program here. Hold on. Maybe I didn't save it. Yep, I didn't save it. There we go. And let me make sure everything is commented out. Okay. There we go. Make sure you save your programs. And this is not very interesting program. It's just going to return top, bottom, front, back, left, right. Cool. So those are the sides you should be using whenever it says which side you're testing. Those are the valid ones. Okay. Let's go back to the program and let's comment that back out so it runs. And the next one API function we want to use is this get input. And if you look at this setup I have a vanilla redstone coming in from the left side of the computer. So it's as you face it, it's the left side. And it's going into a lever and a redstone lamp. So this will get the input and print out either true or false. So let's run that guy. It should get a false because the lamp is off. Let's go ahead and turn it on. And we should get a true. Cool. Okay, that's pretty easy. So you can see you can turn on lights on and off, redstone signals on and off, launch TNT, whatever you want to do. It's really easy to set to get the input. Set the output looks very similar. So I want to basically turn this light off. So right now it's on, and I want to turn it off. Let's see if that works. Hey, it didn't work. What's wrong? Okay, well, you'll know that with vanilla redstone, the on signal dominates. So even though this is saying turn off, because this lever is here, it's making this signal turn on. It's also turning the rest redstone on here. So if we replace this with like a repeater, then this part would be off. Oops. But this lamp would still be on. So the computer will not override levers or anything else. But if we take this guy off, the computer can now turn it off and it can turn it on. Back to the program. And see, it turns it on. And this is going to be on, until the computer shuts down. See, as soon as the computer shut down, it turned that signal off. No redstone signals go out from the computer when it's off. As soon as we boot it up, it turns on. Okay, I'm going to put my lever back. Turn it on there. Go to the code, and I want to turn this guy off. Just for the next test. Okay, so this one's on the computer, redstone signal's off, we still get an on sign. Okay, and in the code, let's go to the next one, which is the get input and get output to show the difference. Let's just run it and then figure out what happened and why we get the results that we do. Okay, so we got a true and a false. Why is that? The redstone signal is on, right? One returned true, one returned false. And this is because the get input returned true because it's just testing the signal and it was on, so we got a signal. But the get output means what is the computer sending out on the left, and it's not turning anything. We set it to false, right? Right there when we last run it. So even though the light is on, the redstone's on, get output will turn false. No big deal. That's just how they work. The same thing works with the get bundled input and get bundled output. I'm not going to show the difference, but let's move on to some cooler stuff, the bundled cables. Okay, so let's run this one just really quick, and it's just going to print the get bundled input to the backside. And right now, I don't think anything is on. What are we going to get? A list of colors? No, we get 0. 0 means everything's off, right? Let's turn a couple on. Red and blue. 18432. Okay, so tell me how you're supposed to tell 184032 means red and blue, right? You could go and you can write a table that says, okay, this is 1, this is 2, this is 4, this is 8, this is 16, and then, do a modulus or something. I don't know. Complicated math to figure that out. No, you don't need to do that. Instead, we're going to go colors is equal to what the backside is, and then I'm going to print colors.test. We should probably name this something different so it doesn't get confused. I don't know if it will. Not test, it's compare. Or is it test? It is test. Okay, I had it right the first time. And we want to test the current colors with colors.red. And so that should, we need another parentheses there, print a true if red is on. Let's go see if that happens. And we got true, okay. One more, let's do colors.test, and in this one we'll do colors.combine, colors.red, and colors.blue. Okay, I think that's right. We don't get any errors. That returns true, but what if we do blue off? We get a false. Okay, what if we turn blue on, but we also turn green on? We get a true because we're only doing a comparison, the colors.test on those colors. So even those other colors on and that number would be different, it's comparing the individual colors. Okay. So that is cool. Comment that guy back out. And now let's look about setting colors. So in this one, we're going to set the output to colors.red. As colors.red. And did I not save? Nope. Okay, so we did colors.red, but blue, green, and red are still on. Same case as this lamp, because this one is overriding it. We turn these off. We turn this guy off. Red stays on, because now it's being powered by the computer, even though this lever is off or on. Okay. So now, let's change our program to say blue. And run that, okay? And I remember what I said earlier about colors being on, states being on. What's going to happen? Blue goes on and red goes off. Did we want that? We may not have. So we go back to the program and say let's get the current colors that are on and combine current colors with blue. 1, 2, 3, 1, 2, 3, okay. Now that should be a comma and leave one less of those. That looks good. Okay, now let's run this, and currently it's going to combine blue and blue. And just keep blue on, but if we turn red on, no, not that way. Oh yeah, I guess we could do it this way. We just have to run it twice. Okay, so now red and blue are off. Okay, so that's how you can do the color comparison. But if you were like, maybe we're testing to see whether orange is on, and if orange is on, turn blue on. We don't need to turn orange back on because we're only checking it. And if we turn it on, then it'll always permanently on. We'll never be able to check it again. That's a problem I did run into the read farm, is I had like 5 different inputs and outputs, and I was testing one, setting them back on, and it was my harvest count was staying at 1 because that was always on, never turning off. I'll tell you guys about that in the Let's Play. Okay. Just occurred to me, I haven't published that episode of the Let's Play yet, so you guys are getting a head start. In one of the episodes of my Let's Play upcoming, I build a reed farm and computerize it. It's really cool. Okay, so let's move on. We're getting about 20 minutes. I want to speed this guy up. Okay, the next one is this test bundled input. This doesn't affect the state. Doesn't turn it on, doesn't turn it off. It just checks it. So we're going to say test if blue is on. Oh, I don't think I printed anything, right? No, I did. Did save it. And we broke the program. Don't forget your RS dot. It also works for Redstone, but I don't know why you'd want to type that out. Don't forget the RS. Save to back here. False. Blue is off. We turn blue on. We can test it. Sure. Okay. That is that. Okay, now we get to some cool functions. We're going to work with timers and events and testing and all that kind of stuff. So here's the first function. It starts by creating a timer. And all we have to do is call the OS API start timer. We're going to call it every 5 seconds. And the ID of this timer is called timer1. And we're going to need that later. Okay, then I'm declaring a function, and this is called a redstone event. And whenever this function is called, it's going to test the backside bundle cable for the red color. If that is true, it'll print red is on. If it's false, it'll print red is off. Okay. We've also got another function called tick that's just going to print tick to the screen and restart that same timer. Remember how I said this timer only executes once. So we want every time we get a tick, we're going to restart that timer. And then we'll go into the meat of the program. It's a repeat loop. And so this section will repeat until a condition is met. This is really cool. I do it in all my programs now. So yeah, I'll show you how it works. We're going to test the, we're going to use that OS pull event that I was talking about. And that returns a couple parameters. Some of the events have more parameters besides P1, like P2, P3, P4. But the ones I'm using only use P1. So this will give us the name of the event, and P1 is usually like the ID or some other value that we can use. So if the event is equal to a redstone event, then I want to call that RS event function. So that means whenever we get an event, we're going to go test if it's, for redstone event, we'll test if the red is on or off. If it's not redstone, let's check and see if it's equal to timer. And that means our timer elapsed, so we had 5 seconds. So if that's the case, we're going to then check if P1 is equal to timer 1. So basically, we could have 2 timers running, timer 1, timer 2, and we wouldn't be able to tell from just the event which timer is finished. So you check the first parameter, and you see if that's equal to whatever you created. Okay? So if we want to check timer 2, we could do timer 2 right there. And if that's true, then we want to call this tick function, which just prints out to the screen. Not do anything really cool with it, but let's just know that our timer went off. Okay, and then the last thing is we're going to repeat, keep pulling new events, pulling events forever until we get an event of type char, or char, whatever you want to say. That means a character was pressed on the screen, on the keyboard. There is a key event, but the key event's P1 is an integer, so X I think like is 45, so I don't want to do that. I want to get the character event, and check if the parameter 1 is equal to x. What this does, it'll make our program run forever until we press the X key on our keyboard and it'll quit. Cool, right? So now we've got an exit button, and you can technically in Computer Graph hold Control T to terminate it, and you have to hold it down usually a little while. But this will automatically just exit our program when we hit X. Pretty cool. Okay, you want to see this run? Let's save it. Okay. And if we wait for 5 seconds here, our timer should go off and we'll get a tick on the screen. Okay, so that's just going to tick every 5 seconds. Not very interesting, other than timers are really helpful in a lot of applications. What if I turn orange on? That's a redstone event, right? Okay, so we got red is off. So even though the orange signal triggered our redstone event, we could still check if red is on or off. Okay, and then we could also do with vanilla. It triggered a redstone event, and we checked that red was off. Okay, I'm going to leave that one. We should get one more off, and let's turn red on. And now we got red is on, and if we turn that guy in, red is still on. Okay, so that's how you can do, check when a signal turns on or off. But what if I just want to know when red's going on and off, and I have all these other cables connected, and they're going to be turning on and off, and I don't want to check red every time. I just want to know when red goes on or off. We have to do a little bit more complicated coding. So let's go back to the program here. Actually, first I want to show you the nifty hit the X button, and our program terminated. Cool. All right, so let's remove this one and come down. And this is nearly the exact same program, but I've got an extra function here called getStates. And this is one I wrote. And what it's going to do is do the get bundled input from the back. So that gets all the colors that are currently turned on at any moment. And what it's going to do is then create an array or a table, whatever this is in Lua. And in the first index, it's going to test if current colors contains red, and it'll set it to true or false. And it'll do the same with red, blue, orange, green, and pink. So basically, we can call this function anytime we want to get a state of our wire, of our bundled cable. Okay, and it'll return that state to whoever called it. Okay, so then we've got pretty much the same program. We're going to start a timer with 5-second interval, and then we're going to get this P state. So that's like the previous state. And I want to get that right away when the program starts, just so I can know, kind of initialize what were the bundled cables set to when the program ran. So now I have all the states of my wires. Then when we get that redstone event, I'm still doing that red is on, red or off, but how do I know if red was the one that triggered this event? And what I can do is I can get the current state. So I call that getStates again, and I save that in CState. And now all I have to do is say, if the previous state in the first index was false, meaning red was off, and the current state is equal to true, red is now on, then I know that the red one was the one that triggered that event. Red turning on triggered the event. So I can handle that. And in my read farm, I do that whenever a read passes through an item detector, I check if this previous state was false, the new state is on. Then I know a read passed through. And then I end that with taking the current state and passing it as the previous state, so that for the next event, I know what the last current state was. Tick's the same, this is all the same, nothing changed. So let's enable this guy. Did we already disable the other guy? Yep. Alright, back to Minecraft. Let's reboot the machine. We're still going to get those ticks, but now if we do an event, red is on. What if we turn red off? Red is off. So it knew the red didn't turn on here because the previous state and the current state were both off. But if now the current state is off, false, and the new state is on, we should get that event. and it said red turned on. So there's a difference between red is on and when red turned on. And that's how you can check a state. Just check the previous one and the next one. And the biggest one here is this line here, setting the previous state equal to the current state after you're done. Okay, we got maybe one or two more. One more that I've got prepared. Okay, so this last one is to show you how to turn something on and then off. When you notice, like when you click a button, the redstone signal goes on, it waits for a little bit, and then turns off. And there's a little bit of a delay in there. And all blocks kind of need that delay to know to update. If you do it too quick, it won't catch it, it'll miss it. And so that's what this program is designed to do. I'm going to run this 10 times. I'm going to set the bundled output of the back to purple. I'm going to wait a little bit of time and then turn all the colors off. And then wait a little time and then repeat. So if I run this, you should see this purple light go on 10 times. It should give us 10 redstone. That's got an applicable use right there, you know. To get 10 redstone out of a deployer is quite the redstone feat in vanilla. Okay, so we got 10 redstone, but what? That took a while, right? You know, I want that faster. Give it to me every 0.1 seconds. Or let's be 0.2 total. But, and save that back to Minecraft. Are we going to get 10 really fast? Wait, what happened? We got none. That's because our signal wasn't on long enough for this redstone block to, or this dispenser to know to put out the stone. And we can do this back to 175, and I think 175 is the minimum. I didn't test every number in there, but I know 1.5 doesn't work, or 0.15. But 175 is definitely works. And so if you just do that one, it will turn that one on. Oh, actually we did get 10. So it looks like it's mainly has to do with how long the color is on, and then we can do a really short off time. I wonder if we have that, it'll work. Yeah, we still got 10. I wanted to watch the lamp here. Yeah, the lamp doesn't go on or off, but our dispenser is actually working with that short of an off duration. So, yeah, so if you want to, what if we did, yeah, there has to be some duration between this one, or it would just turn it off and then immediately on, like if you deleted this line. That would not work, because it would just go off and then back on immediately. But it looks like we can sleep for a very short period of time while the color is off, and then as long as we give it this amount of time on, we should get our thing. So that's what I wanted to show there, and that's all I prepared. The last thing I wanted to do, let me type the code real quick and be back. Alright, and for our last program, I've got the same get states function that's going to go ahead and get the state of all the colors. Save the previous state when it starts up. And when we get the redstone event, it's going to get the current states and also the array of current colors, subtracting pink. And I'll show you why I don't want pink in there. If pState 5, which is the state of pink, used to be false, and now it's true, that we know pink comes on, and I want to print something called randomizing colors. And what we're going to do is take a random number, so this is using the math library, random between 1 and 4, and store that number, and we're going to print it out so we can debug if we need to. And if the number is equal to 1, then we check what the current state of 1 is, which is red. And if red is currently on, then we want to take the current colors and subtract red from it. So that means if we get a 1 and red was on, turn it off. Else, so if we get a 1 and red was off, could take the current colors and add red. Okay, so that'll take all the current colors that are on, not counting pink, and add red or subtract red. Basically toggle it. And it's going to do the same thing with blue, orange, and green. And then remember to copy the current state over the P state. This is the same thing, I took out the timer. Okay, so let's go to Minecraft and run it. And you can see the pink line is on a timer that's running like every 3 seconds. And that's why I don't want to include that in the current colors, because if I set current colors and added red, then pink would always be on and that timer would never tick. That we never get the tick. So that's how you get around that. Nice little trick there. Let's go and boot this guy up. And you should see it say randomizing and pick to 4 this time, which I think is green. And then must have got a 4 again. Yeah, 4 again. Okay, come on, give us something other than a 4. What are the odds? There we go. We got a 2. So it left green on, but it also turned blue on. And then we must have got 3. And I got 2, so it turned blue off. So you can see it each time it randomizes, it toggles. It doesn't turn them on and off. So let's do something fun. Put this at the minimum and watch the disco party. I'm going to make a disco in my Let's Play. I just know it. This is just way too cool. Sometimes, it's totally random when the lights turn on and off. It's really cool. You don't know how long they're going to be on for, how many times. Totally random. And the only thing cooler than a disco with lights going on and off is a disco with music going on and off at random intervals. And I used Automator MC's tutorial on how to make the F major scale, which is 0 clicks, 2 clicks, 4 clicks, and 5 clicks, so that these numbers harmonize pretty well. And you can see every time they turn on or off, you get a nice little music note. I think it's pretty cool, right? You could dance to that. I'll probably have to change it to drumline. I'm going to do that. Okay, now that is cool. Alright, so not the most perfect music, but I'm sure we can find a way to get some cool randomized music. Get maybe a solid drum beat and then randomize some of that kind of stuff, but it's alright. And let's get that timer turned off. Anyway, that's been FunshineX's ComputerCraft Tutorial 5, all about Redstone API. I hope you guys had a lot of fun and learned a lot. Go out and write some ComputerCraft programs to take advantage of Red Power's bundled cables and all that you can do with that. I hope this helped. Next, I either plan to tackle monitors, which is going to be probably quick, so it'll more be about drawing to the screen and that kind of stuff, and maybe what some uses for monitors would be. The other thing that we need to talk about would be modems, so wireless communication. After we get through with those, we've pretty much covered all the basics, and then we'll go into just writing some cool programs that can do cool stuff. So stay tuned for those. Please give me a comment, thumbs up, a like, a share, do whatever you can to spread the word on YouTube so more people can see these tutorials and see how great ComputerCraft is. Talk to you later, guys. Bye.